Problem 2. Problem 2. Rank the following 5 capacitors from greatest to smallest capacitance, noting any cases of equality. Okay. So they're giving us 5 capacitors, a 20 microfarad and 4 volts, 30 microfarad and 90 microcoulombs. Ooh, okay, I see where they're going with this. The capacitor with charges of magnitude this. 2 volts potential. A 10 microfarad capacitor and capacitor storing energy. Alright, so they're basically going to have us play around with the formulas, and this is just a slide trick on their part to get us to memorize them. Not that I disagree with it. I personally enjoy slide tricks, but it's what we're going to have to go with in life. Alright, so first I'm going to write it capacitance equals Q over V. Such a sad looking Q. And I'm going to rearrange this guy so that Q equals CV. And then we're also going to use energy, since I think I saw energy in there. Energy equals 1/2 CV squared. And we'll probably have to rearrange some other things as well. And there we go. Alright, so I'm just going to go from, I guess, top to bottom. Yep. Maybe there's an easy way for me to do this. Maybe. No, I don't think so. Alright. I'm going to do, nope, that's A. There we go. B. Nope, I'm going to use, oh no, I lost a squared. There we go. Here we go. A. You can be bigger. Be bigger, little a. That's a pretty good sized A. Now we'll go there. A. Oop. Copy paste. You'll be the B. Ah, you just went bold. You got me. C. D. Maybe I can double this as like a Sesame Street special. E. There we go. Line up. And I can just copy and paste. Yes. This. Perfect. Excellent. Go team. Alright, and these will be capacitances. Capacitanti. I think it's actually just capacitances. Alright. So for first one, we need to find the capacitance. We're doing capacitance first? Okay, capacitance. So they're giving us, 20 microfarads. Bam. First part was easy. And I'm just going to write 20 because they're all going to be microfarads. And if they're not, I'll note it as exceptionally big or exceptionally small. Okay, next one is 30. Perfect. Capacitor with charges. Okay, so this one gives us charges and voltage. So we need to do 80 times 10 to the negative. So I'm going to do 80 divided by 2. Oh, I can do that in my head. That's 40. 40. And that's 40 microcoulombs. Okay. Then, all right, so now they give us a joules and microfarads. All right. So for this one, we have, I'm going to try and make it, so 2 times energy, which in this case is 125 microjoules, and divided by C. Alright, so I'm going to do 2 times 125 times 10 to the negative 6th times 10 to the negative 6th divided by 10. 10 to the negative 6th. No, it's already in microfarads. Why did I do that? Why did I do that? Why did I do that? That's okay. I was trying to solve for voltage, and I have a feeling that will be useful later. The capacitor storing. All right, so this is the one I was trying to do. So 250 divided by 10 squared is 2.5. 2.5 times 2, I'm doing this all in my head, be 5. That seems reasonable. All right. I should probably actually do this one. So for this one, we're going to have capacitance equals 2 times energy over V squared. So we're going to have 500 microjoules divided by 100 volts squared. 500 divided by 100. Yep, I'm going to say that's 5. Okay, so this is what we need for our capacitance. So we want to arrange it from greatest to smallest. I'm not going to rearrange them. I'm just going to tell you the answers. So all right, this guy, this would be C, B, A, D, 5. E, not 5. E is 5, but so maybe I could say it is 5? I don't know. All right, now the secret's going to be trying to highlight just the letters without the, aha! Ah, darn it. All right, maybe if I get just these guys in, die. Excellent. There we go. There we go. Haha. Success. All right, next one I think was voltage. So now we're going to do the same thing we did before. Now we're going to do it with voltage. Okay. Oof. Rank the same capacitors, check, from largest to smallest according to the potential difference between the plates. Okay. So first one, easy, because they tell us it's 4. 4. Got it? Next one, they tell us nothing. Okay, so we need to figure this guy out. So V is Q divided by C. So Q is charge, which is 90, divided by capacitance, which is 30. The micros cancel out. So we get 90 divided by 30, which is 3. Wow, for giving us such a tedious task, they're at least being nice about the numbers. 3. Okay? Now for C. A capacitor with charges magnitude 80. Oh, 2 volts. Bam! Another success. I feel like I accomplished something just by reading the fact that they gave me the answer. All right, so now this one's going to be slightly more difficult. So now, a 10 microfarad capacitor storing this much energy. So if we look at this formula over here, 2 times E divided by C. 2 times E divided by C. And that will give us voltage squared, which they're going to have to square root to get just normal voltage. And hopefully they'll give me a reasonable number. 15.8. I'm going to say that might be reasonable. We'll see. And then for E, 10. Okay, so now we need to put them from what, greatest to smallest? So this will be D, E, A, B, C. Got it? Okay. Now I think the last thing that I copied was the letters. Let's see if it's true. Heck yeah, it's true. But it also came with the numbers. There we go. See if I can get just these guys. Come on, there we go. I should probably copy these guys while I got the chance. Excellent. They're a little bit higher though. It doesn't matter. All right, so rank the capacitors in order of magnitude of charges. All right, so now we're talking about coulombs here. Be careful with coulombs because the coulomb symbol, C, looks like the capacitance symbol C, so just keep that in mind in life. So we have a Q. My favorite thing about Q is that in cursive it looks like a giant 2. Alright, so the first one, Q equals CV, so they don't give us Q, but I can do 4 times 20, which is 80, and that'll be 80 microcoulombs. Wait a second here. Alright, I'm not even going to read them anymore. I am going to cut to the chase here. I'm going to use my previous calculations to make this one super easy. So 30, I can just do this section times this section equals this section. Bam! If you ever get this kind of question on the test, I would highly recommend setting it up like this. So this will be 90. This one will be 80 as well. Oh, we finally get to use that equal sign. That's a plus. Well, it's not a plus, it's an equals. All right. I'm going to call this 158. Ooh, the other one's going to be 150. So close. All right, so I assume we're supposed to do, again, largest to smallest. So magnitudes of the charges on their plates. Rank the capacitors in part 1. Magnitude of charges on their plates. Okay, we got this. So I'm going to say DEA equals C. Oh no, I missed B. All right, right. D is greater than E, which is greater than B, which is greater than A, which is equal to C. All right. Next, we're going to, come on, still, yes. Excellent. I know that's not an accomplishment in life, but I'm going to pretend like it was. All right, so now we have energy. So I'm going to try and do the same trick. I assume it's energy. Yep. I'm going to do the same trick I did before. 1/2 CV squared. So I'm going to use this times this squared divided by 2. So let's see how much mental math I can do here. So 20 times 16 is 320. 320 divided by 2, 160. And that'll be 160 microjoules. Ooh, I'm going to do this and then check with the problem because I think they gave us a couple of them. So, all right. 30 times 9 is 270. 270 divided by 2 is 135. Oh, right to the edge. There we go. Right, this one is going to be 4 times 40, which is 160, divided by 2 is 80. This problem's not that bad. Not nearly as bad as I thought it was going to be. At least not as tedious. All right, now I'm going to check with this one, see if they just gave it to us. Bam, 125. D is 125. I kind of cheated on that one because I don't know what 15.8 squared is. And I remember it was a funny number because we had to do a square root anyway. So, all right, so this one will be 100 times 5, which is 500, divided by 2 is 250. There we go. Excellent. Make the capacitors in the order of the energy they store. Okay, so we'll say E is greater than A, which is greater than B, which is greater than D, which is greater than C. And bam, got it. Winning. Okay, and that's all there is to this problem. Sounds good? On to number 3.